Welcome back for another deep dive. Today, we're looking at some really interesting research about AI and specifically how smooth its attention is.
Yeah, it sounds a little technical, but it's actually about how AI thinks. You know how it focuses on information?
So we're not talking about like an AI with a smooth voice,
Uh,
more like how it processes information.
yeah, exactly. It's kind of like how our brains focus on certain words in a sentence. The research you sent over actually dug into the math behind how this all works, the so-called attention mechanisms.
So like right now, I'm trying to block out all the other noise and just focus on your voice.
Exactly. So the big question is, does AI attention work like that too, or is it more like jumping between totally different things?
Is it a thing like a human or is it totally different?
Well, that's what the researchers wanted to figure out, and their paper goes into some complex math stuff, like Lipschitz continuity.
Lipschitz what now?
Yeah, it's a mouthful, but basically it's a way to measure how much something changes based on the input it receives.
So like in this case with AI, it's like measuring how abruptly its attention can shift. Like if I'm reading a book and suddenly a fire alarm goes off, my attention shifts really
Yeah,
fast.
exactly. And the researchers found that there's actually a limit to how bumpy AI attention can be. Even if something totally unexpected happens, there's a built-in constraint on how abruptly it can change focus.
Whoa, hold on. So even if you like threw the AI a curveball, it wouldn't just completely derail its thought process.
Yeah, that's the key insight. There's a kind of inertia to its attention. It can't just jump between ideas that are totally unrelated.
So it's not like those movie scenes where a character has a sudden personality change and you're like, what just happened?
That's a perfect example. This research suggests there's a certain smoothness to the way AI thinks, even in extreme cases.
That's fascinating. But it makes me wonder if there are these limits. Does that mean AI thinks differently than humans?
That's a big question researchers are trying to answer right now. It's possible that future AI could be even smoother than human attention. But right now, there are constraints in how the models are designed.
So how did they test this? Did they just throw a bunch of random data at the AI?
Well, they actually designed this thing called adversarial data, which is basically data that's designed to break the AI's attention to make it as jumpy as possible.
So they were trying to mess with it, basically. I like it.
Yeah, and even with this super challenging data, the AI's attention still followed the smoothness rules they predicted. It couldn't be tricked into making a sudden illogical leap in its focus.
It's like they built a racetrack, and no matter how hard they pushed, the AI couldn't break the speed limit.
That's a great way to put it. It really shows that even though AI is super complex, it still has to operate within certain mathematical boundaries.
This makes me think about all the stories you hear about hacking AI with like weird pictures or sounds or whatever. Does this research have anything to do with that?
It definitely does. If we understand how sensitive an AI's attention is, how easily it gets distracted, we can make it more secure against those kinds of attacks.
So it's like figuring out the weak points and then armoring up.
Exactly. And what I find really fascinating is how this research shows both the power and the limitations of AI.
Yeah, it's like we're starting to understand not just what it can do, but also what it can't do.
Right. And that's crucial as we develop these increasingly powerful tools.
Well said. Okay, I'm ready to dive deeper into how they actually measured this smoothness. I'm guessing there's some serious math involved.
You bet. But don't worry, we'll break it down for you. It all starts with this concept of conditional optimal transport, which might sound intimidating, but there's a surprisingly intuitive explanation for it. Okay, so imagine you have two piles of sand, and you want to make one pile look exactly like the other, but you can only move the sand horizontally, not vertically.
Okay, so I can't just scoop it up. I have to like slide it around.
Yeah, exactly. It's like a puzzle where you have to rearrange things, but you have these constraints, and that's basically what conditional optimal transport is all about.
So in the case of AI attention, those constraints are like the rules of language, right?
Right.
Like how words have to be in a certain order to make sense.
Exactly. And by using this method, the researchers were able to prove their theory that even when AI is processing complex language, it can't just jump between ideas randomly. There has to be some kind of smoothness to how it connects concepts.
This is reminding me of how some AI can write stories or poems now. If the AI's attention was too jumpy, the output would probably be nonsense, right?
Absolutely. Smoothness is crucial for creating text that actually makes sense and is grammatically correct. This research shows that even the most advanced AI models can't just ignore the basic rules of language.
It's like even in the world of AI, good writing still needs good structure. So they proved this mathematically, but did they actually test it on real AI models?
They did. They use a really popular language model called BERT, and analyzed how smoothly its attention mechanism worked across different layers. They fed it a ton of different text samples like news articles, Wikipedia entries, all sorts of stuff to see how it handled different levels of complexity.
So they weren't just seeing if BERT understood the text, but how it was processing it step by step.
Right. And what's even cooler is they didn't just measure the overall smoothness, they actually calculated what are called local Lipschitz constants at specific points within the text.
Local Lipschitz constants.
Yeah.
So like they were looking for those moments where the AI's attention might be getting a bit jumpy.
Yeah, exactly. Like analyzing our movie character scene by scene to see exactly when those personality shifts happen. And guess what? They found that the smoothness of Bert's attention wasn't uniform. Some layers were super smooth, while others were more prone to those abrupt changes.
So it's like different parts of the AI have different attention spans. Some are better at focusing than others.
It seems that way. It's possible that some layers are designed to deal with the big picture, the overall meaning of the text, which requires smoother attention, while other layers are focused on the smaller details, the nitty-gritty stuff.
This makes me wonder if understanding these differences could help us design AI that's even better. Like if we know which parts need to be super focused, we could optimize those specifically.
That's a great point. Imagine tailoring AI to be super precise and smooth for tasks like legal analysis where every little detail matters. Or on the flip side, designing AI that's super adaptable and quick thinking for something like a self-driving car.
It's like we're not just building AI, we're actually sculpting its thought processes.
Yeah.
So besides the different layers, did they find anything else that influenced the AI's attention smoothness?
They did. Turns out even AI is a creature of habit. They noticed that Bert's attention was smoother when it encountered common words and familiar grammatical patterns.
So the AI was more comfortable when it was dealing with stuff it had already seen before, just like us humans.
Exactly. It seems that even AI benefits from experience and familiarity. The more it's exposed to certain patterns, the better it gets at processing them. And this has huge implications for how we train AI models in the future.
This whole deep dive is making me realize how much we still don't know about AI. It's amazing. But before I get too existential on you, did the researchers do anything else to test their theories? Like, did they go beyond just analyzing existing models like BERT?
Yeah, they actually went a step further and built their own attention mechanisms with different levels of smoothness.
So they were like, okay, we know there's a speed limit, but what if we build engines that run at different speeds?
Exactly. They wanted to see how changing the smoothness would affect the AI's performance on different tasks. So they tested these custom-built attention mechanisms on things like image recognition and machine translation.
Did smoother attention always mean the AI did better? Or were there times when being a little jumpy was actually helpful?
It's a great question, and the answer is it depends. For tasks that need a lot of precision, like analyzing medical images, smoother attention was definitely better. The AI made fewer mistakes and didn't get distracted by irrelevant details.
Right, you wouldn't want a jumpy AI reading your x-rays.
Exactly. But then there are other situations where you need the AI to be really quick and adaptable.
Like in a self-driving car where it has to make split-second decisions.
Yeah, exactly. And that's where things get really interesting. They found that for tasks like playing video games or navigating a constantly changing environment, a bit of jumpiness in the AI's attention could actually be a good thing. It allowed the AI to react faster to unexpected changes.
So it's like a trade-off. Smoothness for accuracy versus jumpiness for adaptability.
That's a great way to think about it, and it really shows how much we can learn by comparing human and artificial intelligence. Sometimes WE need to be super focused, and other times we need to be able to think on our feet.
This whole conversation is making me realize how much we still have to learn about how AI works. It's like we're just scratching the surface.
I agree, and this research is just the beginning. It opens up so many possibilities for how we can design AI that's not just powerful, but also adaptable, flexible, and maybe even creative.
Okay, before we wrap up, can we just do a quick review of the main points from this deep dive? We've covered a lot of ground.
Absolutely. So first we learned that AI attention is not infinitely smooth. There's a limit to how quickly it can shift its focus.
And second, that limit is determined by something called the Lipschitz constant, which is basically a measure of how bumpy the AI's attention is.
Right. And third, we saw that understanding this concept of smoothness can help us design better AI for different types of tasks.
So sometimes we want smooth and reliable AI, and sometimes we want it to be more flexible and adaptable.
Exactly. And as research continues, we're going to learn even more about how to fine-tune AI attention to fit our needs. It's a really exciting area of study.
I'm definitely fascinated to see where it all goes. but I think we've given our listeners a lot to think about today. So to wrap things up, I have one final question for everyone out there. If we can already control the smoothness of AI attention, what's next? Can we actually teach AI to decide when to be smooth and when to be jumpy?
Ooh, that's a great question. It really pushes us to think about how we can make AI even smarter and more responsive to the world around it.
Awesome. Well, thanks so much for joining me on this deep dive into the world of AI attention. And to all our listeners, keep those brains buzzing, and we'll see you next time.